Geometry, Unit 2, Section 2, angles formed by parallel lines and a transversal. So there's a couple of important angle relationships that happen when two parallel lines, and that's what we see here. These are two parallel lines, these two, and they're cut by what's called a transversal. That's what this line would be called here. A line that intersects multiple parallel lines is called a transversal. And the way we denote parallel lines on the picture isn't by highlighting them. We put little arrows on them like that. Like that means that is parallel to that. And if we had other parallel lines, they might have double arrows to separate from these parallel lines. And the parallel symbol looks like this. This is how you would say AB is parallel to CD. You know, I don't think there's letters on here, but if this was AB and CD, you know, something like that. And so the first relationship we want to point out to you here is this relationship here. This angle here and this angle here is what we call corresponding. Because there's two parallel lines intersecting the transversal, there's two groups of angles. There's the group that is caused by the intersection up here, and then there's also the group caused by the intersection down here. So two separate groups. If I were to take these angles and put them on top of these angles here, the angles that fall on top of each other are called corresponding angles. So this angle and this angle are corresponding to each other. And what that means is that they're congruent and they're equal in measure. The same goes for this angle and this angle, and this angle and this angle, and this angle and this angle. They're all corresponding. So there's four pairs of corresponding angles. Again, a good way to think of it is if I were to take these angles and put them on top of this, the ones that fall on top of each other are corresponding. So these two things right here are very similar. They're just kind of going back and forth. And what it says, I'll just read it real quick for you, is that, I just want to get rid of that. I guess I can just erase it. If parallel lines are cut by a transversal, then corresponding angles are equal in measure. So if I know these lines are parallel, and this is obviously a transversal, then I know these angles are congruent, equal in measure. The other way around that is I can use that to prove the lines. Say I don't know the lines are parallel, but I know these angles are equal in measure. Well, that proves these lines are parallel. So if two lines are cut by a transversal and corresponding angles are equal in measure or congruent, then the lines must be parallel. So it goes both ways. If the lines are parallel, the corresponding angles are congruent. If corresponding angles are congruent, then those lines are parallel. A couple others. This one is what we call same side interior. And the rule for same side interior. Now, why do you think they're same side? Same side because they're on the same side of the transversal. Like this is the left and this is the right. They're both on the left side. And we call them interior because they're inside the parallel lines. And where corresponding angles are congruent, same side interior are supplementary. So these two angles would add to 180. Same thing with these two angles over here. They would add to 180. And then the last, which is probably the most important, is alternate interior angles. So they're interior because they're inside the parallel lines, not out here, not outside. And they're alternating sides of the transversal. One's on the left, one's on the right. These are called alternate interior angles. You'd have another pair right here. So you have two pairs of alternate interior angles. And they are equal in measure. They are congruent to each other. This concept of alternate interior comes up a tremendous amount in this course. So this is a major concept. And often we use that to prove parallel lines all the time. If we have alternate interior angles congruent, that means the lines are parallel, and that's something we could use in a proof. So alternate interior is big. There's also alternate exterior and same side exterior and stuff like that. But we'll just stick with these for now. So we're looking at this diagram, and given these planes, I want to list all the pairs of corresponding alternate interior, same side interior. So let's run through that. But notice again that the relationship we have that there's other things happening here other than just corresponding and alternate interior. Just look at one group for a second. We have vertical angles here, right? That B and C are vertical angles. And G and F are vertical angles, right? And A and D are vertical angles, and E and H are vertical angles. But since B and C are congruent because they're vertical, and C and F are congruent because they're alternate interior, and G and F are congruent because they're vertical angles. All four of these angles are the same measure, and we kind of have a zigzag pattern happening there. And it's the same thing with the other grouping. A and D are vertical angles, so they're equal in measure. D and E are alternate interior, they're congruent. And E and H are vertical, so they are all the same measure. So there's really only, when we see two angles cut by a transversal like this, there's really only two angle measurements out here. Like if this is 50, then this is 50, then this is 50, then this is 50. And if that's 50, well, A and B aren't vertical. They're not alternate interior or anything, but they are supplementary because they form a linear pair. And so they add to 180. And so that makes this 130 because they add to 180. And then this is 130 because they're vertical. And this is 130 because it's alternate interior with the 130. And also remember what we said about same side interior, that these 50 and 130 are same side interior. They're supplementary. They add to 180 also. And this would be 130 because it's vertical without 130. So there's really only two angle measurements in this whole problem. Corresponding angles, that would be, the pairs would be A over here corresponds with E over here. Again, if I take this group and put it on top of this group, they fall on top of each other. So A and E, B and F, C and G, and D and H. It's okay if you wrote all over this, but I'm going to erase it to kind of show you what I'm talking about again, that a D and H, here's D, here's H. That this angle right here and this angle are the same angle if I were to put this group on top of that group. And they also kind of form a little bit of an F pattern. That if I were to highlight that for a second, if I were to highlight this, and the transversal, notice I get a little bit of an F pattern here. Corresponding angles do that. Same thing with all these other pairs, you know, A and E. So here's angle A and angle E. You know, it's kind of an upside down F, but it's like an F pattern for angle A and E. So corresponding angles have that pattern come up a lot. And there's four pairs. All right, how about alternate interior? Alternate interior, there's just two pairs, C and F. So it's this angle and this angle. And alternate interior angles don't have an F pattern, they have kind of a Z pattern, right? So here's angle C and here's angle F. So they kind of form a zigzag or a Z pattern. And the same goes for the other pair of alternate interior angles, D and E. And then lastly, same side interior, that's going to be C and E and D and F. Now, these corresponding are congruent, and alternate interior are congruent, but same side interior, that's a supplementary relationship. C and E add to 180, where C and F are congruent. C and G are congruent. So there's congruent relationships and alternate interior relationships. All right, let's try a couple quick problems. All right, what's the measure of the angle here? So this is a corresponding relationship, so they are congruent. So angle A would be 48 degrees. This is same side interior, so that's a supplementary relationship. They add to 180, so that's got to be 132 plus 48 equals 180. This was a corresponding relationship. These are alternate interior angles, so they are congruent, so C is going to be 48 degrees. And this is, well, we used to call it alternate exterior. I don't really say that much anymore, but the best way to think about this is D is congruent with this angle because of vertical, and that's congruent with this because of alternate interior, and that's congruent with 48 because of vertical. So D is equal to also 48 degrees. I have a couple more challenging ones. I'm going to find all of these angles here. All right, so 53. First of all, that's corresponding with this 53, so angle A is 53 degrees. And that 53 is, well, these two are supplementary because they form a linear pair there. And these two are supplementary because they're same side interior. So they add to 180, so that's going to have to be 127. So angle C is 127 degrees. And this B is also 53 degrees because it's vertical with A. That's another 53 degrees. One more quick one. All right, what do we think about here? Well, let's see. This 35. Now, I could extend this line if I want, but I'm actually not going to. Instead, I'm going to say that this is 35 because that's an alternate interior relationship, right? See that Z pattern. I know these lines are parallel. See these little arrows? Right? That means parallel. So that's why I'm allowed to say this angle is 35 degrees because they're alternate interior angles of parallel lines. And then D and this 35 form a linear supplementary pair. So that would make angle D 120, not 120, 145. That would add to 180. And of course, you could use your calculator for assistance on the algebra if you need. All right, we'll practice more with parallel lines and transversals and these angle relationships in class.